Question number 10 of the worksheet, connected particles. Particle A of mass 1.26 kg and particle B of mass 0.9 kg are attached to ends of a light inextensible string. The string passes over a small smooth pulley P, which is fixed to the edge of a rough horizontal table. Okay, so the table is rough, meaning there's going to be friction, either just force of friction, or if they talk about coefficient of friction, then we're going to break it into mu r. A is held at rest at a point 0.48 meters from P, and B hangs vertically below P at a height of 0.545 meters above the floor. The coefficient of friction between A and the table is 2/7. That means friction would be mu r. A is released and the particles start to move. Show that the magnitude of acceleration of the particle is 2.5 and find the tension in the string. Meaning we'll be using simultaneous equations. So let me copy the figure again. Okay. Okay. Okay, so let's start entering the forces that we know. There's going to be a downward weight, which is going to be mass times 10, the gravitational acceleration. So it's going to be 0.9 times 10, so 9 newtons. Okay. Then there's going to be a tension pointing upwards. Then there's going to be a weight pointing downwards here, mg, which is going to be 12.6 newtons, and an upward force, which would be the normal contact force, a force of tension towards the pulley, a force of friction, which would be mu r, in the opposite direction. The movement is going to be in the downward direction, and for A, it's going to be towards the right. Okay. We have to form two simultaneous equations and then solve them. So at B, the equation is going to be forward force minus backward force is equals to MA, equation 1. And at A, it's going to be forward force, which is T, minus backward force, which is mu R, is equals to M, which is 1.26 A. Okay. T minus mu is 2/7. R is opposite to 12.6. So R should be 12.62. Sorry, yeah, 12.6 is equals to 1.26 A. That's equation 2. Let's simplify. 2/7 times 12.6, 3.6. Equation 2. Solve these simultaneously and tell me what you get for T and A. Acceleration should be 2.5 as shown here, and find T.
A is 2.5 and T is 6.75 newtons.
That's right. So A should be 2.5 meters per second square, and T should come out to be 6.75 newtons. Let me know if you get a different answer. Next is find the speed with which B reaches the floor. So we need the speed when B reaches this point right before it hits the ground. So what do we know about this part of the journey? We know that U is 0. We know S is 0.45. And we just found acceleration as well, 2.5. Now we need to find V, the velocity right before it hits the ground. So we can use V square equals U square plus 2AS. V equals square root 0 square plus 2AS, which gives 1.5. Next is find the speed with which A reaches the pulley. Okay. A common mistake made here is what students do is they look at this part of the journey and they say that U is 0, which is right, because initially A was at rest. That's right. Then they say that the acceleration is, what was the acceleration that was found? Acceleration was 2.5 meters per second square for both the particles because they're connected particles. And then the distance covered till the between the pulley and the particle is 0.48. And then they use this information and find V, which is going to give you a wrong answer. You can't use this acceleration. You can't use this distance. Why is that? Because look at the distance between B and the floor and A and the pulley. Distance between B and the floor is less than 0.48. So when B covers this distance, A covers this much distance. It doesn't go all the way till the pulley. It reaches here. Okay, so this distance covered would be 0.45 and then 0.03 is still left. So there's a distance of 0.03 left to cover. So S is actually 0.03. So the distance you need to um, use is going to be this distance, which is going to be 0.03 meters. So we're going to say S is now 0.03 meters. And you need to find V, the velocity before it uh, reaches the pulley. And we know the speed here because the particles are connecting, it's equals to the speed here. So that came out to be 1.5. So this speed is going to be 1.5. So U for the final part of the journey is 1.5. Now we need to find the final speed. So we either need acceleration or we need time so that we could use the equations of motion. There's no mention of time anywhere in this question, so we just ignore T. That means we have to somehow find A of the yellow part only. अब मुझे कोई बताए कि एक्सेलरेशन तो हम पहले फाइंड कर चुके हैं ये वाली, तो ये क्यों नहीं यूज कर रहे इधर? हमें ग्रीन पार्ट की तो एक्सेलरेशन पता है, that was 2.5. Then why am I not using it in the yellow part? अभी तक क्या हुआ है? कि बी ने इतना डिस्टेंस कवर किया है एंड इट रीचेस द ग्राउंड 0.45. इतनी देर में ए ने इतना डिस्टेंस कवर किया है ना, इट आल्सो कवर्स अ डिस्टेंस ऑफ 0.45. So the distance left to cover is 0.03. फिर हमें अगर इस पॉइंट पे स्पीड चाहिए तो उसका मतलब है इस पॉइंट पे स्पीड चाहिए, क्योंकि कनेक्टेड पार्टिकल्स हैं, वो पहले ही निकलवा चुके हैं 1.5. चलिए एस भी पता चल गया, यू भी पता चल गया. अच्छा अब रह गया ए. अब why is this A going to be different than the A of the first part of the journey? That is because in the first part of the journey, the string was completely stretched. But now, as B hits the ground, the string is going to slack. Okay. As B hits the ground, because of the impact, there's going to be some slacking in the string. And when the string slacks, its tension becomes 0. So there's no tension in the string now. So T is equals to 0. Forward force becomes 0. So we can find acceleration using T. Now we're talking about point P. No, not at point P, at the new position of A. Let me call that A dash. So at A dash, there's a forward force, which is T, which is actually 0 because the string has slacked, minus backward force, there's friction, mu r is equals to ma. Okay, so T is 0 minus mu is 2 by 7. R for A was 1.26 is equals to 1.26 into A. So these and these get cancelled. So A is equals to minus 2 by 7. Okay. Okay, A is coming out to be something else. Wait a second, I've made a mistake somewhere. Let me fix.
Ma'am, isn't R supposed to be 12.6, not 1.26?
Yes, exactly. That's why I'm getting a wrong answer. R is opposite to the weight, not the mass. So it was supposed to be 12.6. Okay, अब A सही आएगा. So these two can't be cancelled out now. So minus 2 by 7 into 12.6 divided by 1.26. हाँ अब सही आ रहा है. Supposed to be minus 20 by 7. Okay, so that's the acceleration. Okay, but we're not done yet. अभी तो हमें खाली acceleration मिली है of the final part of the journey. So जब slack हो गया, यहाँ पे that's the new position of A dash, string slacked है और यहाँ पे पुली है. तो पुली तक आना है, उसमें we know that U is now 1.5 as discussed earlier. जो इधर का V है वो यहाँ का U हो जाएगा. Okay. और डिस्टेंस हमने देख लिया था 0.03 है और A अभी हमने फाइंड कर लिया -20/7. A has changed because the string is not slacked anymore. I mean, the string is not taut anymore. Now it's slacked. और जब slack होता है तो टेंशन 0 हो जाती है. तो फिर फॉरवर्ड फोर्स माइनस बैकवर्ड फोर्स इज इक्वल्स टू ma से आप न्यू एक्सेलरेशन निकालोगे एंड दैट कम्स आउट टू बी -20/7. अच्छा अब क्या रह गया, स्पीड v चाहिए, स्पीड विद विच इट रीचेस द पुली. So we can use v square equals u square plus 2as. which gives 1.44. कोई क्वेश्चन है तो प्लीज पूछ लो.
Ma'am, why'd you take T as 0?
Tension as 0 because now the string has slack. It's not stretched anymore. So there's no tension in it. जब stretched होता है तो T होता है. जब वो stretched ही नहीं है और slack हो गया. और slack क्यों हुआ है? क्योंकि B has hit the ground. और उस impact की वजह से string slack हो जाता है.
Okay.
So that's why tension becomes 0. Any more questions? Okay. If there are no questions, then we start question number 11. Okay, let me copy the figure again. Yep. Particle A of mass 0.26 kg and particle B of mass 0.52 kg are attached to the ends of a light inextensible string. The string passes over a small pulley P, which is fixed to the point of a smooth plane. So the plane is smooth, that means no friction. The plane is inclined an angle A to the horizontal where sine A is this, cos A is this, and A is held at rest at a point 2.5 meters from P with the part AP of the string parallel to the line of the greatest slope of the plane. B hangs freely below P at a point 0.6 meters above the floor. A is released and the particles start to move. Find the magnitude and the acceleration. Okay, let's start to plug in the forces. At B, there's a downward force of 5.2 newtons. For A, it's not a horizontal surface, but an inclined surface. So this time, there's going to be two components of the weight. The weight itself is 2.6. I'm going to write 2.6 cos theta and 2.6 sine theta. In fact, instead of theta, I should be writing alpha because that's the symbol they've represented the angle with. Okay. And then we have R in this direction. And then we have T in this direction. There's no friction this time. Okay. So let me substitute the values for cos A and sine A as given in the question. So also there's a T in this direction. So 2.6 cos A means 2.663 over 65 and 2.6 sine A is 2.6 into 16 over 65. First one is 2.52 and the other one is 0.64. Okay, so I'm going to write that here. This is 2.52 in total, and this is 0.640 था कि 6 था? 0.64. Okay. Now we have to find the tension and the acceleration. So let's use forward minus backward is equals to MA. So at B, it's going to be 5.2 minus T is equals to 0.52A. And at A, it's going to be forward force is going to be T minus backward force is going to be 0.64 equal mass at A was 0.26 A. Solve these and give me the value of A and T. क्या आ रही है A और T की वैल्यू? Yes, no one has the values for tension and acceleration yet. आयशा आप फाइंड कर रहे हो? आलिया, अजहर, दाऊद?
Yes, ma'am, one sec. Acceleration is 5.85 and
Right.
tension is 2.16.
Yes. Okay. So we have the A and we have the T. So part one is done. Part two is the speed with which B reaches the floor and the distance of A from P when A comes to instantaneous rest. Okay. So we need to keep the acceleration in mind. The speed with which B reaches the floor, so that's straightforward. Okay. So B reaches the floor after covering a distance of 0.6 meters. So S is going to be 0.6. When B started off from rest, so U is equals to 0. Since the string is still stretched, because there hasn't been an impact of B with the floor yet, so we're going to use the same acceleration, 5.85. Okay, so now we use these three to get V. V squared equals U squared plus 2AS. V equals square root of 0 square plus 2 times 5.85 times 0.6, which gives 2.6486. It's going to be 2.65. Okay, so the speed with which B um, at which B reaches the ground is this 2.65, which is this speed here. This speed is V is equals to 2.65. Now the particles are still connected because this is right before the impact. Impact के बाद तो ये speed 0 हो जाएगी. So right before the impact, the speed is this 2.65. अच्छा अब इतनी देर में A also has covered this journey of 0.6 meters. So यहाँ पे 0.6 meters का distance cover हो गया और इस position को मैं A dash position कह रही हूँ. अब at this position, starting from A dash all the way till P, अब I'm going to call this U equals 2.65. Because for the yellow part of the journey, the U is 2.65. Okay. It's saying that find the speed with which B reaches the floor, done, and the distance of A from P when A comes to instantaneous rest. Okay, let's say A will come to instantaneous rest somewhere over here. Why is that? Because as soon as B hits the ground, the string slacks because of the impact और A को वो पुश करके ऊपर की तरफ लाएगा, पुल करके, सॉरी, स्ट्रिंग. सो इंस्टेंटेनियस रेस्ट पे would be the highest point for A और उस पे V is going to be 0. This is V. So we know U is 2.65 for the yellow part of the journey and V is 0. The acceleration is not going to stay the same because after the impact, the string slacks. So अब tension 0 हो गई है इस part में. So the forward force is T, which is 0. Backward force में वही weight आ जाता है mg sin theta क्योंकि there is no friction on the plane, so mu r नहीं use करेंगे. So अब I'm going to use at A or at A double dash. Forward force is tension, which is 0 since the string has slacked. Minus backward force is just mg cos theta. So 2.6 cos alpha. Sorry, that one is sin alpha. Cos नहीं होता, cos तो r होता है. Okay, is equals to ma. A is what we have to find. Sin A आपको already पता है, it's 16/65. अब find A from here. It's going to be a negative value. क्या आती है? It's negative 2.6 into 16/25, 16/65 divided by 0.26. 2. 6. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26. 0.26 It comes out to be,
negative 2.46.
yes, negative 2.461. Okay. Now you have the acceleration for the yellow part of the journey. उसमें string slack हो चुका है, तो इसलिए tension of a slacked string is 0. So new acceleration आती है. पिछली वाली acceleration खाली तब use होती है जब string stretched हो. अच्छा जी, A भी आ गया. So A is this. So now you use these three parameters U, V and A to find what? S find करेंगे पहले. S. So U, V और A से S. V square equals U square plus 2AS. So 0 square equals 2.65 squared plus 2. A is minus 2.461 or S is what you have to find. Tell me what you get for S. और खाली आलिया ही मुझे लगता है आज पढ़ रही है, बाकी या तो कंप्यूटर के पास नहीं है और हैं तो पढ़ाई नहीं हो रही, because I'm not getting any answers from anyone else. Please start talking. S निकाल के बताओ मुझे.
मैम नेगेटिव 2.1.
नेगेटिव तो नहीं आ सकता.
मैम दूसरी
मैम
साइड
आई
पे
एम
नहीं
गेटिंग
लगा है?
1.43.
नेगेटिव क्यों आ रहा है? देखो देयर इज ऑलरेडी अ नेगेटिव है. देखो ये नेगेटिव टर्म है, इसको दूसरी साइड पे ले जाओ, पॉजिटिव हो जाएगी. So then you have positive terms on both sides.
It's 1.42.
हाँ जी, 1.42 थी. 1.42 meters. अच्छा. ओके. अच्छा, अब क्वेश्चन ये था कि फाइंड द डिस्टेंस ऑफ ए फ्रॉम पी व्हेन ए कम्स टू इंस्टेंटेनियस रेस्ट. तो अब ए ने पहले इनिशियली 0.6 मीटर्स का डिस्टेंस कवर किया था, ठीक है, जब ये ए डैश तक आया था. ठीक है, फिर ए डबल डैश उसकी हाईएस्ट पोजीशन थी. यहां से यहां तक स्ट्रिंग स्लैक हो गया था क्योंकि इम्पैक्ट हो चुका था. सो द स्ट्रिंग हैड स्लैक और उतना डिस्टेंस था इनके बीच में 1.42. So now the distance left between P and this highest point for A is going to be S or whatever is equals to total 2.5 है minus 0.6 plus 1.42. इससे वो blue distance आ जाता है, which comes out to be 0.474 meters. चलो 12 और 13 अब होमवर्क में करोगे. And I'm sending you guys a new link to discuss the last 4 pure paper questions.